We're going to talk about fragments today, and we're going to start by looking at what a fragment is and how they're used. We're going to talk about the fragment lifecycle as well as how we create fragment transactions using the Fragment Manager. We're also going to look at design principles, some considerations that you are supposed to have in mind as you work with fragments in an application. And we're also going to look at all of this by implementing fragments in a basic application. So what is a fragment? You can think of a fragment as a modular piece of an activity. It is, in and of itself, a separate component from an activity, but they are oftentimes used as a way to compose an activity, both in terms of layout, that is what the user sees, as well as functionality, that is what the activity does. You can essentially combine multiple fragments inside of an activity to compose its behavior, either all at the same time or by swapping fragments in and out of an activity based on the action the user is performing. By way of example, you could imagine building an email application where your main functionality might be viewing your inbox or another folder, reading an email, and composing an email. In such an application, you could take a design approach where a single activity is used as the main container, if you will. And then each of those top-level functionalities that I mentioned can be implemented in their own fragments. So I could have a fragment that is responsible for displaying the contents of an email folder, such as your inbox. Another fragment that has the responsibility of showing the details of an email, allowing the user to read a message. And a third fragment that allows the user to compose a message or reply to a message. From there, this activity can simply swap fragments in and out or display multiple fragments at the same time, depending on the configuration of the device and the current state of the application. Essentially, by using fragments, we can build dynamic user interface that can respond to changes in device context or application state. Here we see an illustration of that example. So you could imagine an application where, as you see on the left, again in the context of an email application, we could have a list of email messages. And then on the right of the list, we can have the details of a selected message. Now, this list detail flow can be applied to a lot of different application types. You can imagine wherever I have a collection, and upon selecting an element from that collection, I view details, then you can apply this pattern. On the right, you'll see the way that fragments allow us to change the way the application behaves. In this context, we are running our application on a smaller screen, where showing these two interfaces at the same time would not be advantageous to the user. Fragments allow us to break up that interface where we can display the collection or the list of elements as a single screen. And then upon selection, we can then display the details of the selected item, whether that's an email message or a song or anything else. So you can think of fragments as building blocks. They are modules that allow us to compose an activity to offer different either UIs or functionality to the user. These fragments can be contained inside activities or inside other fragments. So generally we refer to the container as either the host or the parent. Fragments, much like activities, have their own life cycle, and the life cycle of a fragment can be impacted by the life cycle of its host or its parent. So for example, if a fragment is contained in an activity and that activity is paused, then the fragment will also be paused. And each host, that is an activity or a fragment that contains other fragments, has what's called a fragment manager. And that fragment manager allows us to essentially manipulate fragments within the host. So adding or removing fragments as basic examples of some of the operations that we can perform. Here we see the life cycle of a fragment. As you can see, it has similar callbacks to the life cycle of an activity, with a few more callbacks and therefore states that are added when we consider that not only is a fragment essentially impacted by the life cycle of its activity, but a fragment can have its own set of events that will trigger certain state transitions. So simply we see that our fragment starts with an onCreate. In fact, there is a callback prior to this called onAttach, where we can actually get an instance of context, but we'll see how that can be useful or relevant later on. After onCreate, we have onCreateView and onViewCreated, followed by onViewStateRestored, followed by onStart and onResume. So here we see three callback functions introduced that do not exist for an activity, but again, they all relate to specific state transitions that can occur for a fragment. From onResume, we can have onPause. We can transition from there to onStop. OnSave instance state, we know that this is a callback that does in fact exist for an activity. OnDestroy view, which correlates to onCreate view, and onDestroy. So again, much like with an activity, different things can cause different state transitions in a fragment. And when a particular state transition occurs, the respective callback is invoked, allowing you to execute code that relates to that particular state. Now, we mentioned that every host that is an activity or a fragment has what's called a fragment manager. So the job of a fragment manager is allow us to perform fragment-based operations, as well as get specific information about the state of our application as it relates to fragments. So we can do things like add or remove or replace fragments within a host, or we can search for fragments, check for the presence or absence of a fragment. We can reverse transactions, because a fragment manager will maintain a set of transactions on what's called its backstack, similar to the way activities are stored in the backstack of a task. Fragment transactions are stored in a backstack managed by the fragment manager. So a fragment manager can be accessed in a couple of different ways, depending on where you are trying to access the fragment manager. So from inside of a host activity, you can access the fragment manager that will manage fragments in that activity by referencing support fragment manager. So you do not create your own fragment manager object. The fragment manager is already there. You simply use the support fragment manager reference to access it. If you would like to access the activities fragment manager for whatever reason from within a child fragment of an activity, you can do so by referencing parent fragment manager. If, however, you want to access your own fragment manager from within a fragment so that you can manipulate fragments that this fragment is hosting, you would reference child fragment manager. So how do you create a fragment? Well, creating a fragment is accomplished simply by extending the fragment class or some subclass of the fragment class. And from there, you implement the necessary life cycles. The onCreateView callback is perhaps the most ubiquitous callback that gets overridden in a fragment implementation, as that is the callback where you will inflate or create the layout that forms the UI of this particular fragment. From there, that UI or that view object is returned and is thereafter embedded in the activity. And that's what the user then sees when the fragment is attached to a host, attached to an activity or another fragment. If the attached fragment is not going to contribute to the parent's layout, to the parent's UI, then you can just return a null reference from your onCreateView function. Once onCreateView is implemented, assuming you are contributing to your parent's UI, you can thereafter implement other callbacks as necessary depending on the state transitions that you want to respond to. And we'll see examples of that later on. So let's take a look at how we can create a fragment in an Android application. So here we see a very basic application that contains a set of drawables. So these are essentially a set of images. And what we would like to do here is create what we're going to call an image fragment. And the job of that image fragment will simply be to display an image, either one or a set of images, depending on what you're trying to accomplish. In this example, let's say we want to display a single image at a time, but allow the image to be selected at random whenever the user interacts with the fragment. So a single image being displayed, but that image will change whenever we click on the fragment. So to do that, we're going to create a fragment. Creating a fragment essentially requires that I create a new fragment. And in a fashion similar to creating an activity, there are a set of templates that I can use. And you can also select gallery to see what those templates look like, the very, very basic illustration of what those example templates would look like. For this and for all future examples, we're going to select a blank fragment. The idea is we want to kind of do everything ourselves. So I can select blank fragment from here or from the list or from the menu. I can just select fragment blank. Both will work. Then I'm asked to give my fragment a name. I'll call this image fragment. My fragment is going to have a layout file generated by default. So I'm going to leave that, hit finish. And now I'll see that my application has a new fragment called image fragment, or a new class called image fragment. This class, among other things, extends the fragment class. So it inherits everything from fragments. So this is what makes it a fragment. And inside, I can see I have a new layout file called fragment image, which right now just has a frame layout as the root element and contains a text view. Now, before I get to designing my layout, I'm going to hop over to my fragment class and I'm going to do some cleanup. So as you can see, there's a lot of code generated here. And the reality is, for now, we don't really need any of this. All of the generated code here serves a purpose. They facilitate implementing certain patterns or certain features in fragments. And we are, in fact, going to visit all of these and talk about them. But for now, we just want a very basic fragment. So I'm going to pretty much delete almost everything. So I'm deleting everything up to the import statements. I'm going to delete the properties. I'm going to delete the onCreate function. I'm going to leave onCreateView, and I'm going to remove this companion object and the function contained in it, leaving me with just onCreateView. So this is objectively easier to look at, easier to read. This is the callback that is going to essentially inflate and return the layout that this fragment is going to use. Fragment image, fragment image. So this is the simplified version of my fragment. So I'm going to come back to the code in a moment. First, let's set up the layout file for my fragment. So I'd mentioned that the job of this fragment is to display, let's get some more screen real estate here. The job of this fragment is to display an image. That means my fragment basically just needs an image view. Placing it in the frame layout, and because this containing view, the root element is a frame layout, the rules governing the child view are going to be a little different than if it was inside of a constraint layout. Now, we don't want to get too into the weeds, but the long and short is, depending on what you're trying to accomplish, you have a few options here. You could leave the frame layout as the root element and simply manipulate your the properties of your image view accordingly. You could set the frame layout, rather remove the frame layout and have a constraint layout, something that you're more familiar with, as the root element, and then arrange the image view within the constraint layout as you see fit. Or, and this is key, if it is the case that your fragments layout will only have a single view inside the root element, inside the layout, then you can actually make the single view be your layout. In other words, a layout is just a view. So if I was only going to have this image view, or if this image view was going to be the only item in my layout for my fragment, then I could get rid of the frame layout and just make the image view the root element. So I could do that simply by making this an image view and giving it the ID that I want. So those are the options that are available to me. It's really up to you how you'd like to do this. I can't really speak to any obvious optimizations that you get one way or another, but it's at least a good little trick or thing to be mindful of as you're building applications that use fragments. Obviously, if I am going to use a layout that has more than one view elements, then it's not possible to make the view, or in this case, the image view, the root element. I would still need a container, like the frame layout or the constraint layout. All right, so I'm going to leave this as the default. I'll leave this as the frame layout. I have the image view, and the layout is done. For now, at least, for my simple application, I don't need to do anything else here. So now my job is to essentially set up the behavior, the logic, the functionality of my fragment. This is what my fragment is going to look like. It's going to have this image or this image view, but how does it function? Well, the first thing I'm going to need to do in order to set up the functionality is I want to have my application do something when the user clicks on the fragment. For all intents and purposes, the only visible piece of the fragment will be this image view. As such, what I can do is attach an on-click listener to this image view and then execute whatever code I want to have run when the user clicks. have that be triggered inside the on-click listener for this image view. So that means from my fragment, what I'm going to need to do is grab a reference to the image view that is contained in this layout. So this layout file that is going to be inflated contains the image view. If I had made the image view the only element, or make it the root element, then that means this inflated layout would itself be the image view. But in this case, the frame layout is the layout. So that means in order to get access to the image view, I need to go inside of this layout. So I can do this in a couple of ways. I could first hold a reference to this layout. And then from here, I could grab a reference to the image view that is contained inside the layout by simply calling layout dot find view by ID, the function we're used to. We're used to calling this on our activities, which would allow us to find a view that is inside the layout used for the activities content view. But you can also call find view by ID directly on a layout or directly on a view object, and that will allow you to search inside that layout for a specific view. In this case, the view we want is, of course, an image view, and the ID was r.id.imageview. That will now allow us to access or manipulate the image view found inside the layout. And from here, I can now return the layout. So instead of doing a direct return here, I first hold a reference, extract my image view reference, and then return the layout. So that's the sort of the step-by-step mechanism I have for doing this. Another way that is more Kotlin-esque might be to use one of those scope functions. So I could do something like return this layout. But before you do that, I would like you to apply this scope function. And in this scope function, I want to find the image view with r.id.imageview. So I'm calling this on the context object, this layout. So I'm finding the view inside the layout, and then I'm going to add an on-click listener. So this allows me to simply find the image view, attach an on-click listener, and then once I've set up that functionality, return this layout, the thing that contains the image view, to the caller, which in this case is going to allow that view to be attached to the parent activity, or potentially inside of another fragment if this is going to be a fragment housed inside of another fragment. So from here, I just need to figure out what this application or what is supposed to be triggered when you click this image view. So what I'd like to do is essentially have one of these images be displayed at random. So for that to function, the first thing I need to do is to get access to each of those items. So I can do that, of course, by just creating an array. So I could specify that the images are going to be an array of, and then from here, I can essentially spell out each of the types, the image views. So it would be r.drawable.caramel apple, r.drawable.celebration, lather, rinse, repeat. There we have our array of resource IDs for each of the drawables that we have in our application. So from here, what I would like to do is essentially have this image view which is this it reference. However, this it is currently being treated as a view. So because I want to assign set the image resource, I need to tell Kotlin that this is not just a view, which is how the unclick listener treats it. I need to tell it that it's not just a view, it is in fact an image view. So I'm going to take this and I'm going to cast it as an image view. And then set its image resource to be one of the images in the images array. Now, in Kotlin, I can actually extract a random element rather, from the array by simply calling random on my array reference. Otherwise, I would have to do something like take the size of the array, then generate a random integer from 0 to the size -1, and then extract the from the index using that that random value. By just calling random on the array, that all of that is done for me. So this is the functionality that I'm essentially looking for. I want to, whenever I click the image view, I want to randomly show one of the images. So that essentially is the functionality of my fragment. What I need to do now is essentially add this fragment to my activity. Now, when I add a fragment to my activity, what we're going to see by default, and certainly in our case, is that the fragment's layout is going to be displayed inside the parent, inside the activity. So it will essentially become a part of the parent's view group. So it's important to understand that even though our fragment is inside the parent and it shows up as if it's a part of the activity, the fragment does in fact have its own layout, and it needs to manage things like its own set of event. It must have its own event handlers because it's showing up in the activity, but it is its own module. It's its own piece of discrete code. Now, we had mentioned before when we were implementing our fragment that it is not necessarily the case that the fragment contributes to its parent's layout. If it is not necessary for the fragment to show up, then you can just return a null reference. In that scenario, whenever the fragment is attached, it's invisible to the user and it just acts as a worker. So you can still write code that gets invoked whenever the fragment transitions from one state to another. It's just that it won't be visible to the user. So how do we actually add the fragment? Well, we can do this in a couple of ways. We can add the fragment to a container, to our activity in this case, as a child element, essentially, either at design time, that is where we are doing that inside of an XML, or at runtime, where we are writing code in order to accomplish this. Now, regardless of how you add a fragment, you need to specify a container. That is, you need to basically outline where the fragment is going to go, whether you're doing it at design time or at runtime. You create a space for a fragment in a container's layout by adding a fragment container view to the layout of the host. So in our case, what we're going to do is hop over to our activities layout file. So notice I'm not going to the fragments, I'm going to the activities layout. And I'm going to add a fragment container view. So adding the fragment container view is prompting me to select the fragment that's going to be displayed here. This is essentially what happens if you're adding a fragment at design time. It's going to have a reference to the class, and it will show up inside the fragment, or rather inside the parent, automatically when you run your application. Now, that may be what you want in some cases, but it won't always work. So what I'm going to do is I'm going to add my fragment at runtime using code. And the first thing I'm going to do is fix this rendering bug. So as soon as I added the fragment container view, the layout disappeared. I need to bring the layout back. So I'm going to go ahead and click on the little error icon. And it's telling me that it doesn't know the fragment. What it's basically saying is it doesn't know the layout that is supposed to be used to show what fragment is going to be in that container view. If we switch over to code, we'll see that these are the attributes that are currently in the fragment container view, but it's missing something. It wants to know which layout should be used here. So I can either use one of the layouts that are already added to my project, or I can pick one from the list. So if I do that, it adds this new item, tools layout, because this is not something that actually affects my application. It only affects the rendering inside Android Studio. So now it shows up. This is not an image view. This is the layout from the fragment, or the layout that we're using for the fragment. So that's what we're seeing here, and it's showing up as an image view, as if it is an image view inside of my activities layout. But this is actually the layout for the fragment. So what I'm going to do here is I'm going to add this fragment container view. I'm going to constrain it because now this is inside of a constraint layout as we're used to. And I'm going to set the width and the height to take up as much room as possible. This is called Fragment Container View 2. Doesn't really matter what it's called, but let's call this Image Fragment Container. So I call this Image Fragment Container. And this will essentially hold an instance of my fragment, of my image fragment. That's its job. Now, it turns out that right now, if I run my application, the fragment will actually be there. Because recall when I added the fragment container view to my layout, it asked me to select the fragment I want to add. It assumes I want to add that fragment at design time. So when I selected it, it referenced that fragment class. This means the fragment is going to be added automatically. So if I were to run my application now, I would actually see the fragment and it would in fact function. So let's see what that looks like. Right now we don't see anything, but recall that I had added logic to my fragment that said at the point in time where I click on the image, it should select one of the images at random. So clicking this gives me an image. Click again, another random image. Click again, another random image. So I've added the fragment to this container because the reference is inside the fragment container view as an attribute, Android name with the class name. So that is one way that we can add a fragment to an activity. The other way is to do this at runtime, where instead of specifying an attribute within the layout file of the container, we create what's called a fragment transaction, which essentially allows us to use code to create an instance of the fragment and add it to the activity when our application is running. So we're going to change our application to add a fragment at runtime instead of at design time. So what we're going to do is we're going to take this reference that was automatically added to our fragment container view. We're going to take this attribute and delete it. Now, it's important that we take this step and that you remember to remove that attribute if your goal is to add a fragment at runtime. It's easy to forget because Android Studio always prompts you and will not allow you to add a fragment container view automatically or by dragging it into the layout unless you select a fragment. And after we select that fragment, we sometimes forget to come back and remove it. If we don't come back and remove it, then when we add a fragment using code, what we will end up with is two fragments in our layout. The one that was added at design time and the one that we add at runtime. That is not what we want, so we have to make sure we remember to remove the first reference. So now this is just an empty container. There is no fragment here, and no matter how much I click, nothing happens because there is nothing. This is just an empty container. So what I'm going to do now is hop over to my main activity, and I'm going to do a few things. First, I'm going to create an instance of my image fragment, which is as simple as creating any other object type. So this is simply image fragment. And now I want to add this fragment to the activity. To do that, I will first get a reference to the Fragment Manager. Now, to get a reference to the Fragment Manager, I don't need to create a reference because you don't create an instance of a Fragment Manager. Rather, the Fragment Manager is accessible from within an activity by calling support Fragment Manager. So I already have a reference. I don't need this. What I will want to have a reference for, at least in the short term, is to what I'm calling a fragment transaction. And a fragment transaction is what will allow us to create or specify the operations that we want to perform. Adding a fragment to a parent is an operation. So that is an add operation that we can perform by using a transaction. So once I've begun the transaction, I can now specify the operations I want to perform. So in this case, on my fragment transaction, I want to add to the location r.id image fragment container. This is the ID of the container I specified in the activities layout. So here, my fragment container view has the ID image fragment container. So I'm adding to image fragment container that fragment instance I just created above, image fragment. That's the operation. Now that I've specified the operation, I can now commit that transaction, which will execute it. The idea is when you create a transaction, you can specify an arbitrary amount of operations that should be executed. Adding fragments, removing fragments, replacing fragments, etc. And after you've specified all of the transactions you want to execute, you call commit to actually have them execute. And it's important that you call commit, otherwise nothing happens. So running my application now, I'll see that even though nothing is added at design time, I now actually have a fragment here and I can see it because when I click, my image is displayed. As I mentioned, if I did not commit, then even though I described a transaction or all the operations that should take place inside of a transaction, the transaction is never executed. So nothing, clicking doesn't result in anything. So I must make sure I commit. What's more is I can combine all of these statements into a single statement by exploiting something called the builder pattern. The builder pattern is a design pattern that essentially allows you to chain a set of function calls together in sequence, because every function that you invoke or every function call that you make will modify the object on which it is executed per the definition of the function, but it will also return a reference of the same object, thereby allowing you to essentially make another call on the returned object. So it means that something like this can look like this. Support Fragment Manager begin transaction is going to return the transaction object. Directly on that transaction object, I can call add. When I call add, that's going to return the same transaction object, which means I can call directly on that transaction object commit. So it's really this, right? I'm just breaking it up across multiple lines, but I'm basically starting a transaction, adding the fragment, so I'm calling the add function to execute the add operation, and then I'm committing. What's more is because I don't need to use this reference to the fragment in later code, I don't even need that reference. I can just create an instance of my fragment directly. So now I've turned all of those lines into a single statement with the same result. I can see if I click, I get my image. So that's essentially it. I've created a fragment that contains an image view and contains logic. So it has its UI, it has some logic. And then you may ask yourself, well, fine, but what was the point? Why couldn't I just have had an image view in my activity and attach an on-click listener? Well, the idea here is modularity and reusability. The simple fact is, if displaying random images like this is something that would be useful to me, not just in this activity, but in other activities, or not just in this application, but in other applications, then by creating this, taking this modular approach and placing the UI and the logic specific to this functionality inside its own component, which I can then add to activities as necessary, this becomes extremely reusable. And it allows me to do things like, for example, utilize multiple instances of a fragment, even in the same activity. So if I wanted to add, say, another instance of this fragment to this activity, I could do that. So all I would need to do is, from the activities layout, I would need to add another container. And to do that, I'll just add another fragment view container, or rather fragment container view. And what I'm going to do is, I'm selecting the fragment. What I'm going to do is, I am going to change the size of my first fragment view container. So I'm going to search for %, and I'm going to set its height to 0.5. Okay, after adding my second container view, fragment container view, just like last time, my UI is not rendering, so I need to fix that problem, just like I did the last time. So clicking it, I'm being asked to add the layout. Which layout should be used here? Same as last time. I'll just select the same layout file. So here is the first fragment. I changed the first fragment container view. I changed its layout constraint height percent attributes to be 0.5, which is 50%. And then I will constrain the second fragment container view to the first, so I don't need to be explicit with its size. It will just take up the remaining space because I will tell it to match constraint. So they'll both be 50% of the height. So this is the second fragment. Now, just like last time, by default, it has a reference to the image fragment. Again, this might be what you want. Maybe you want to add it at design time. That is not what I want to do. So I have to remember to remove it, and you have to remember to remove it. Otherwise, you will run into problems. You'll spend a lot of time trying to debug your code, trying to understand why you are seeing some functionality being executed in your app when you didn't add a fragment. So always be mindful of that. And the ID here is fragment container view 3. I don't like that one. So this is image fragment container. I'll call this image fragment container 1. And I'll call this one, well, I'm supposed to refactor it. So let's do it from design view so that it does the refactoring everywhere in our application. So I'll call this image fragment container 1. There's a little dialog that pops up. You aren't seeing it, of course, but it asks me if I want to refactor. I say yes. And then for this one, I'll call this image. I completely forgot what I called the first one. The first one, I called it image fragment container 1. So this will be image fragment container 2. Now, all I need to do to add a second fragment to my activity is add another transaction where instead of adding it to image fragment container 1, I add it to image fragment container 2. So now I have a single transaction that is performing 2 add operations. It's adding an image fragment to image fragment container 1 and another image fragment to image fragment container 2. These 2 add operations are going to be executed when commit is executed here. And the result is I now have 2 image fragments added. So if I click the top, there is my image. And if I click the bottom, there is that image acting independently of the first. So that's a very basic use case for designing and adding fragments to a container, to an activity. There are some considerations that you want to keep in mind when building fragments, and you're going to see these considerations playing out as we use fragments more and more in subsequent applications. So first, you want to make sure that you use fragments to fully exploit things like screen real estate. So you saw this in an illustration earlier where you can use single fragment displays on small screens, but multiple fragments on large screens, or even the same screen but in landscape mode versus portrait mode. And you always want to design fragments to be modular. That is to say, ensure that your fragment is as self-contained as possible. It should not know anything about the outside world, and instead should be provided with the information that it needs to operate without knowing what else is going on around it. So that's going to be more and more meaningful in subsequent applications that we're going to work on. But it's always something that we want to keep in mind as we incorporate fragments in applications.